So today we are doing a webinar for Rhinoceros 3D, or more popular, just Rhino 3D is all right as well. The topics we're going to speak about is why to use Rhino in the first place, what is Rhino, basic difference between NURBS and subd, which are the object types of the software. We're going to talk about what different types of objects we can make, lines, surfaces, things like that. And I will talk a little bit about transformation logic, which is related to parametric design. And then we are finally going to do the modeling workflow of the Breuer chair. And we have some time also for possible questions, but feel free to speak at any time. You can stop me, make a comment or a question, not a problem. And also just to let you know that this is being recorded, so it will also be available at the end. We will post it to our YouTube channel and you can review it later. So to start, let me talk a little bit about myself. My name is Stephanie Marx. I am Brazilian, but I have been in Budapest for about 5 years. I'm currently doing my master's at BME in the Faculty of Architecture. And I also have been at HungerCAD for almost 2 years now. Mostly in the past, I have been engaged with workshops and other tasks related to Revit. And I started to have an interest in parametric design, or more specifically about the software Rhino and Grasshopper, not because of this crazy shaped architecture, but more for the power of automating some tasks. So some boring tasks, we can leverage the power of Rhino and specifically Grasshopper to automate. Today, I want to show you a few common use cases of Rhino. So we will touch on the basic things. And mostly Rhino is known for, you probably heard people saying that this kind of architecture, this kind of organic shape is used in parametric design by Rhino, or which is actually more specifically with Grasshopper. And Rhino actually has a lot more possibilities. So all of these images are things that people created in Rhino. And you can have many other examples in the gallery forum of the website. I will show you soon. Other examples, for example, other examples are for product design, industrial design, and it's a very known software for professionals that use CNC. I'm not sure if everyone is familiar with CNC, but it's the acronym for computer numerical control. So CNC is a manufacturing method that automates the control, the movement of these machine tools that cut or fold metal and plastic. So for example, this kind of product is achieved with CNC tools. Other very common use case of Rhino is the jewelry design. Obviously, you can see from this picture, we're talking as well about 3D printing. And the software itself, it can export more than 50 different file types. So it's a very flexible software, and it's a tool that all of these designers might choose for those reasons. Now, if you have no experience with it, you can have a 90-day trial. And to find it, you will basically open the website. You can find rhino3d.com website. It will open this page. And if I click here and download, I will have Rhino 7 for Windows evaluation or Rhino 7 for Mac evaluation. This trial license is for 90 days. And after that, you will have to buy a license key. But the most important thing to mention, this license key is a perpetual license. So you only need to buy it once and you will have the access to the software forever, basically. to that version that you bought. Coming back to the presentation, talking about what is Rhino. If I give you a few quick history topics, basically Rhino was created as a tool for NURBS modeling in AutoCAD. I will tell you what is NURBS in a second. And we have the first release in 1998. So it's a quite old software, you could say, but it has become way more popular and famous with the Grasshopper integration. So when the Grasshopper, which is actually a plugin, was introduced in 2008 is where it started its fame, I would say. Also, is good to mention that in December in 2020, we have since then the Rhino inside Revit release. So I can bring back and forth the geometries between Rhino and Revit. And we will definitely have a workshop just for this in the future. Also, another important thing to say is that the next version release date is not official yet, but there has been a few videos out on YouTube already about what are the features coming, and there is a work in progress version available, so people can try the upcoming features. Now, like I mentioned, what are NURBS? NURBS is considered the base of Rhino, and the acronym is the acronym for Non-Uniform Rational B-Spline, which in a very simple term, very simple way to say, is that this is a mathematical way, a mathematical model to represent 3D geometry. You can think of like from school when you had to calculate all of these quadratic functions and make their graphs into parabolas and things like that. So NURBS is referring to this mathematical model that can represent 3D geometry. And because it's a very precise and well-known definition, it's used in many softwares, and it's what makes it possible to use it for CAD and manufacturing, CNC and other things like that. Now, the other type of object, let's say, that we have in Rhino, which actually came from Rhino 7, available from Rhino 7, not the previous versions, is what we call sub-D, which is the acronym for subdivision surfaces. So the difference between a NURBS surface and a subdivision surface is that the sub-D is a curved surface represented by basically a polygon mesh. So you have, for example, different ways of, or what we call subdivision schemes. For example, if you have this 3 cubes together and you take each edge and make it into a further mesh, you can create a more, let's say, subtle form, or even a more way closer to a proper sphere, let's say, rather than something funny like that. And this is a common picture to show the difference between the two. You can see that if I try to model, this is actually coming from Rhino, by the way. So if you try to model this rubber duck toy with a NURBS kind of geometry, you won't have very subtle, very organic forms. You can see, for example, where you connect this piece and that piece, you have a very abrupt way of connecting, I would say, whereas this one is a much more organic. And we won't cover sub-D right now because this is quite intermediate or more like expert level. To talk about Rhino, we need to understand about the object types. Each software has basically the same types, but naming differently. So in here in Rhino, we will have curves, surfaces, solids, and meshes. And obviously points as well. So the smaller unit is a point, which is a representation of an X, Y, and Z coordinate, basically. And then we have curves. You can have open curves like this green one, or you can have closed curves like the blue one. we have surfaces, which is a 2D demonstration. Then we have the solids and the meshes. The solids can either be an extrusion. So for example, from this rectangle, I can create an extrusion that becomes somewhat a solid, or I can create what we call a closed surface or a closed solid, which is the sphere, for example. And in this case, this sphere is going to be a NURBS sphere. And the difference for the sub-D is the meshing. I won't talk much about this because it can be very confusing. Let me show you a bit the user interface. I will open the software to show it better in here. So when you open Rhino, you will get this basic screen. You will have also here, because I already had it open, it won't show me, but you can also select open recent files or open new file. Basically, you can also achieve that clicking here, new file, and it will give you a few templates. So if I want to model a large object, or if I want to model a small object, and it also gives you the units. So for example, for today, I will use the centimeters. Right. But about the user interface, we have here on the top the name of the file. Right now, I didn't save it, so I don't have to quickly save it. Workshop, something like that. So you can see the name of the file, the size of it. Next, you have the menu, where you have basically the commands of Rhino by function. So you have solid. If I click here, I have a list of the commands. I'm just hovering actually, sorry. Next, I have this ribbon of the selection filters. While I'm modeling, if I want to select only curves, for example, I would uncheck all of the other ones and check the curves. So I select only curves. Next, we have the command prompt and the command history, basically. And this is where we can remember, like I said, this was based on AutoCAD. So they brought this idea of command-based software to Rhino, which is very nice. And you can have on this command line also the options. For example, I can just make a line, or I can make a vertical line, or all of the options that I have for the command line. And also it will show me the steps. It's asking me to create the start line of the line. Now it's asking me to create the end of the line. So that's basically what I just did. Next, we have this toolbar. Again, it's grouped by function. So I have, for example, curve tools, and then it will show me all of the commands here, and it will also show me all of the commands related to that group in here. Look that when I change to surface tools, also changes on the side, solid tools. Usually the tools on the sidebar are for creating new things, solid or whatever, or curves. And on the top here, I have the tools to change, to make some kind of transformation. For example, this offset is one famous command. Next, I have obviously my viewports. Right now I have these 4 displayed. I could come here and change my views. For example, if I change it to 3 viewports, or I can maximize and minimize from here, or I go back to 4. I can also move them around from here, for example, to resize them the way I want. On each viewport, you will see the title and this little arrow where if you click, you will have the viewport menu. You can also change many things in it. For example, the display option, the display of that viewport. If you want to render, display, ghosted, you will see that better when I'm actually modeling something. And if I want to focus or to do the same thing that I did here, the maximize, I can double click. I will maximize that viewport, and I can double click again to minimize it. Next, I have on the bottom here, these are my OSNAPs. OSNAP is short for object snap. So if I want, for example, to do a line that starts exactly at the midpoint of another line existing already, I use the midpoint object snap. And to have that midpoint object snap, I need to have it activated here, which brings me to the last line. Basically, in this last line, you will have this, which is called the status bar. You will have the X, Y, and Z coordinates. You can see that it changes as I move my cursor. Also, all sorts of positions. You will have the units and also the layer that you are currently drawing in, and also these options of the constraints. The most useful of them, usually I would start with the OSNAP, the Smart Track, and the Gumball, always on, and sometimes also the Grid Snap. Grid Snap is basically doing the same thing as the snaps, but it allows you to snap to this grid that you can see. This grid is, you can see these bigger rectangles, bigger squares in this case. They are 10 by 10 unit, and the smaller ones are 1 by 1 unit. And what is the unit? The centimeters, which is my file. So these are very helpful for precision modeling. And next I have the properties, or rather the panels on the right side. I usually leave it on my properties, layers, materials, textures, rendering, and the help. In the help button, you can at any time write a command and you will have the material how to do that. So it will show you this, it will tell you the steps and the different options, how to achieve each of them. You can, if you don't remember how to use a command, you can just type it there. Okay, so to customize this, I can click with the right button and you will see these are all the options that I can have on my right side. For now, this is going to be enough. And if I go back to my presentation, you can have here the summarizing, let's say. I will leave this for a second, so in case you are revisiting this later, you can have this screen. Now, let me talk a little bit about the transformation logic that I mentioned before. So first I will show you an example. Usually when we are modeling something in any kind of 3D program, we approach 3D modeling with in a way of creating boundaries, let's say. So for example, if I want to create a box, I would select a command, let's say rectangle. I can select an option, for example, I'm going to start from the center. I click once, I click one more time, and I created a rectangle. Let's say I want to create then a extrusion out of it. I could use the extrusion command, or I can use the gumball. This is what you are seeing right now, is the gumball. Is something that is activated when I select my object. And it's activated here, by the way. You can also make sure it's on. And with the gumball, I can do a few actions without having to use commands. So it's a shortcut. Somewhere I can rotate my square. I can move my square freely. I selected the wrong command. Or I can move it by a set distance in any of the directions, and I can also extrude a set distance. I clicked the wrong. Okay, there we go. So I extruded my rectangle. Right now you can only see it as a wireframe, and that is because I have here my display view as wireframe. So I can just come to ghosted, for example, is one that I like to use because you can see the back of the object as well. And you could use shaded, for example, where you can't. Right now, this is not exactly a solid. If I click on it, I can see here on the right side on the properties, the type of the object. So it's an open extrusion because I don't have the top and the bottom. But if I wanted to create a box, I can use the command box. And it's asking me first corner of base. Let's say I will come to my top view. Oh, and also, if I want to change from one top view to the other, I can just do it by hovering my mouse. I don't have to click on the view to activate it. So like you see, now my mouse is at the perspective viewport. If I go to the left, I'm at the top viewport, and you can see that it's active because the title becomes blue. So if I start, for example, in the front, I can click here, the other corner of my box, and now I want to define a height. If I'm at the top, I can't really see the height. I cannot use the grid to help me. So I could go to the front and click, for example. I could also do that in the other views. Another useful thing is to use my wheel. So the wheel of my mouse has a few shortcuts. What I want to show you right now is the zoom. So I can zoom extents, and it will show you as well that when you hover up on top of the command, it shows you different commands to do with the left click and with the right click. So if I click the right, it will zoom extend on all of them. So what I was talking about was about the creating boundaries approach that mostly we use in these 3D modeling softwares. And if I come back to my presentation, when we want to think parametrically, we need to start thinking a little bit different. Basically, we should develop our computational thinking skills. And this is about a thought process when you are trying to fix a problem. You are either automating something or you want to create a very intricate shape. You should think how to do that in a way that can be represented by computational steps. So instead of creating a box like I just did, you should think, how can you tell the computer to draw that box or that cube? And the way that that's done, usually in Grasshopper, it uses what we call transformation logic. That basically is a way of representing or modeling something, thinking of the smallest unit and how to transform it into what you want. So you start with a point, which is defined by X, Y, Z coordinates. These coordinates are numerical parameters. So you define the point with this numerical coordinates, and later you use some actions to transform it into a 3D object, like using move or copy or these kind of actions. And I like this image, it's very helpful to remember. This is the kind of thing that we also seen. I guess everyone studied this kind of things in school. When we talk about the point, we have a 0D dimension, XY coordinates. If I want to make a line, means I'm going to move this point somewhere with a direction and a dimension. I'm going to connect these 2 points. And the same way until I achieve the 3D, which is the cube, I will move this line to become a square and this square to become a cube, basically. And why am I saying that I'm going to copy this point and connect it? Because this copy is a kind of a command that can be set as an input. This is what we call an input, numerical parameter input. So this can be changed in a kind of iteration form later. This is the basis of parametric thinking, computational thinking, but right now we are going to focus on the chair modeling so we can get acquainted really to how to use Rhino. And once we understand more how to use Rhino is when we should go further. So I will start modeling if there is no questions. Right. So to model my chair, I will open my right view and I will import a reference picture. I can just type picture for my command. It will open the browser. I will find reference picture in my browser. And it's showing here is asking me to define the first corner of the picture. I will select the origin point, and then I will select any other point just to place it. And now I'm going to scale it. So I use the scale command, define a base point. Let me uncheck the grid snap because I want to define not a specific point. And to be sure that I'm going to do it vertically, I'm pressing the Shift key, which activates on the bottom here. You can see the ortho being activated, meaning I can only select point in an orthogonal way. So let's say this is my reference line. And what I want to scale it, I want to this distance that I set to be 20 centimeters. So I will write 20 centimeters and press enter. You can see it got way bigger. Let me check if it's correct. I will use a dimension to check, more or less. It was this and that, 20, perfect. Now to make my life easier, I will give a little bit of a transparency to this image. I came to the texture, right now, the material, sorry. And I will change its transparency. So when I'm drawing my lines, it won't be in front of, I can see properly my lines. And what we are going to do basically is trace the shape of these arms and legs and create 3D objects off of it. So the command I'm going to use for that is the curve, which in Rhino is set just as a curve, but in other softwares might be known as spline. So what is a curve? As I draw points, it will have those points as a control point, right? So I can use that to make a continuous curvy line. And then I'm just going to start tracing on top of this image that I know it's scaled, so it's going to be more or less accurate. One tip is that when I have a curve here, I want to do this curve, I should give 3 clicks. So it will at the beginning, more or less at the middle, and at the end. Later on, I will come back and make it more accurate. To pan on this view, I am using my right click on my mouse, and I will create some more points. Basically just tracing this shape of the arm. Okay, this was my last point. Now, as you can see on top here on the prompt, I can just press enter when I'm done. And also spacebar will work as well, just like AutoCAD. What I want to do now is select my curve. Oh, I forgot one step. Let me just lock this image so I don't select it by mistake in the future. I can just select it and use the command lock, or I can also use my wheel. I have here the lock objects as well. So now I want to adjust a little bit to make it nicer. And when I click on it, you will see that the points that I created don't really appear. That's because I will have to turn them on. So I use the command point on or a PON shortcut. So I use the PON shortcut and it's asking me to select which curve I want. I select it, press enter, and now I can see the points. So what I'm gonna do is select the points and move them so that they look a little bit more accurate. I could, as you can see now, the gumball is showing, and I can move them on the right direction that I want using the arrows, or I can use this free movement, which is gonna move my point only in the plane that is showing. So it's on the green and red point on the X, sorry. Maybe I should move this a little bit down. No, up. I'm not gonna be 100% accurate because this is just to show you the idea. I'll move this a little bit down. And my end is not very nice. Maybe I should move this dot, this control point. No. If I want, I can, to make this look better, I can add control points as well. So if I come to the curve tools, I will have here this option with the arrow. It will show me different commands that I can use to edit my curve. And I click on insert node. And we'll insert one in there. Now we can move it. It's better. And that's all right for now. So next I will trace the next leg. Again, I will use my curve command, and you can see that they connect each other here. So I will use my end OSNA. Click a few times here. Here. Press enter when I'm done. Now again, I need to turn on the points. I can either use the command first and then select the object, or select the object and then type the command. It's similar. So I will move all of this down a little bit. This is maybe too much, like that. Now this curve is definitely so pointy. Okay, this all. I rotated a point, which doesn't really change anything. Okay, I'm gonna move this a little bit in, and these two as well. And this one goes down. This picture is not a orthogonal projection, so also I am not following 100% because it won't give me the proper curve. Here I should meet them a little bit better, so I'm going to come here and add a point, insert control point. somewhere here is enough to make my curves meet a little bit nicer. Right, so now I have these two. And what I'm gonna do next is make an offset of them. So I will use the command offset, select my curve. And as you can see, as I move my offset of my mouse, sorry, it shows the direction of my offset, but the distance is not what I want. So I can just click here to change the distance. Let me use 2 centimeters, for example, and it looks better. And then I select the direction. I do the same here. To repeat a command, I can use either the right button or the enter. It also repeats the last command, so I don't need to click to type offset again. I'll just do the same. Let me show you how it looks on the perspective. Right now, all of these lines are in the exact same plane. You can see the top view here, which is not exactly how they look. If we examine the picture better, we see that this leg that I made, this one, is actually to the inside of the other one. So I will select these two curves and I will move them. I will just click on the top view here to move them on my X direction, and I will type my unit to be precise, 5 centimeters. Now, what I want to do is to create surfaces out of those curves. And what I need for that is to close these lines, because currently they are just open curves. How I can do that is with the line command. As you can see, it's snapping to the end. Let me open this, maybe better. When I hover above that point, which I want to start my line, it becomes white. That means that it's snapped. So I know that I'm selecting the end point, and then I select the other end point, and I created the line there. I will do the same for the other end of it, and also for the other leg. Okay. I want to use a command called surface from planar curves. So what I need for that is a closed curve. Currently, if I select all of these curves, you can see here that it says 4 open curves. And the command I want to use needs closed ones. So I will use the join command, and now it became a closed curve. I can do the same thing with the mouse wheel. I have here the join command as a shortcut. To find the tool that I want, I will come here to the surface tools, and over there I have surface from planar curves. I select the command and I select the curve. And again. Now what I need to do is extrude them. Select the surface and extrude 5. Same thing with the other one. 5. Okay, so now I have the legs. I will hide them so I can make my seat. I can use the hide or the shortcut for my mouse wheel as well. You have hide and show. So later when I come here, I can just click with the right click and it will show me them back. So for now, I'm gonna hide them. I'm gonna come back to my right view and do the same tracing for the seat. Okay, so I have more or less my seed. Just fix it here a little bit. I'm not tracing it perfectly, but we understand. Okay, now I have it traced. And one important thing to notice is that when I come back here, let me bring back my legs. So the curve that I just traced is over here at the left of the legs, but actually, if I inspect the picture correctly, I will see that the seed starts on the top part, on the right side of this leg, and on the seed part, it touches the right side of this leg. So I actually need to curve it, let's say, in the other direction. So I select it first. I will move to this position. But what I want to do is to move some of the control points to the right side of this. So what I'm going to do is I'm going to turn the points on again. Points on. And I can do it in any view, but I'm going to select them from this view. I want to move all of these points to the right side of this leg. So I will do that. I could have also done it with the precision, so with the distance. And now you can see that the curve does this little kink, let's say. My next step is to mirror all of that. I'm going to open the top view. So basically what I need to do is to mirror this to have the same thing on the other side. For that, I'm going to do a line as a reference line. I select the end of this one, and I will type 50 centimeters, let's say, is the distance. I will select the whole thing and use the mirror. Start of mirror plane is going to be my midpoint. And the end of it, you can see that the line shows it. I can delete this reference line now. Oh, why is the... So here I have, let me go to the perspective. What I want to do now is to create a surface between these two curves. And I will use the loft command. Oh, sorry, I was inside the wrong command. I will use the loft. These options are not important right now. I'm just going to click OK, and that will create a lofted surface between those two lines. I can then use this and offset surface. I need to select the curve. Oh, sorry, I selected the wrong command. I need offset surface. Select my surface, enter, and you can see the lines of where is that surface gonna offset towards. I can click here and flip all, or I can just click on the surface itself. It's gonna flip it. And I can also define the distance. So for example, I want 1 centimeter, let's say. I gave a click to define the new distance, and I give another enter to make the offset. Now I have only 2 steps left, which is setting the material, just for us to have a nice idea of how would that look like in real life. So I come here in my materials tab, and I will add create new material, but I will import from the library. This will open Rhino's library of materials. I have all of these types. I will come back down here on wood, and select one of them, maybe this one, double click. Now this only imported it. What I could do is drag it and drop it. And you cannot see anything right now because my view is set to shaded. To be able to see the materials, I need to be in the rendered view. There you have it. Another way of doing it is selecting all of it, clicking or selecting the objects that you want to define. Click with the right click and click assign to objects. Now you will see that all of them have the material. But if I come closer, the veins of the material, the texture is not really correct, especially for the arms part. In real life, you don't really have these veins in this direction. So what I can do is come to the textures and edit my texture. This is not done in the materials tab, it's done in the textures tab. I have selected this texture and I will come down here where I have the mapping. I can resize it and I can rotate it. So if I give a 90 degrees rotation, you can see now that it's in the other direction. And I can also change the size, maybe 20 would be nicer. And that is it. So we could render this view, or we could also export it just to show it. We have export selected. Let me select this, give an enter. And you can see here the many different types of files that I could export, for example, as, where do I have OBJ? There we go. I could export, for example, OBJ, and that would be very easily to handle in other 3D modeling softwares. I can also export it as the DWG, Illustrator, so it will be vectorized, and many others. And that is it for our modeling. I would like to see if there is any questions. We have about 7 minutes, but I am free. We can also stay longer. I'm sorry, I needed to allow to talk. I hope you could hear me properly. Anyone has any question? Oh, all right then. I thank you for the attention. And if you have anything regarding Rhino or Grasshopper, if you are interested in some trainings or anything like that, you can also contact me. This is my email. And again, this session will be made available later on YouTube, so you can also follow through. Thank you all.